That's how wet my back is after going on my little interview. See if I can help out. This is how wet this is. This is soaking wet. It's on my back. So I was pretty upset with that. It's too hot, but then I see this. Oh no, what's this? You know, look in the fridge. Da-da-da. Ah, I have the best girlfriend ever. Love you, babe. Ah. Just what I wrote here on the board to explain to the math class how everything works with what I'm working on. So start off with the simplest part. This is the trough reflector. It reflects all the sunlight to a pipe. Other bikes?
Veinte, treinta, cuarenta, cincuenta, sesenta, setenta, ochenta, noventa, cien.
Nice. So this shower head actually heats up water inside the head, and it's electrocuted me before. It's also steamed, and that's why it's all bent. And the second one actually melted and steam shot out of there. So I don't like this thing. I don't like it at all. So what I'm going to do is just like the old style, fill up the bucket to shower, but looks like this water is very green. I don't know if that's good or not. And because it's melted, it goes against the wall, so I can't really fill the bucket. Plus it's spread out. So I have to put this cookie sheet there to try and deflect more water into the bucket. It seems to be working quite well, but it's pretty warm water. If I touch it up higher, that's where it starts electrocuting you. And yeah, I'm just going to take that bucket to splash water on myself for a shower. I have to shower with this very green water. It's very gross. I don't know why it's so green, but I hope it's not deadly. Hacking. You have to put your hands on the computer. Hacking. One of Candice's students made this for her. It's really cool. So you just take an apple and you just cut it the right way. It looks like a bird. I have a fan. Much cooler. Way less energy than a stupid air conditioner. We have a phone, yes. Excellent. You can get a reasonable amount of distilled water per hour. So this would be feasible to help people drink water that live close to the ocean. It's working very well. On a large scale with more steam, definitely be great. So I'm just about to change the water. So I get the cold water and I pump it through to cool the pipe and to continue condensing. So these are the parts for the water pump that I made mostly out of garbage. So that's it. That's the pump. And this cost me somewhere about 50 cents to $1 to build this pump. And if I really tried, I probably could make it all out of garbage. So this is, I'm thinking that in developing countries where you need to get water out of the ground or out of a well or a pump from the ocean or something, you could make this out of garbage for very, very little money. All you have to do is go into these countries and show them how to do it and try and motivate people to build things and improve their own living situation. Pop it all the way, and I got it to squirt out the little air hole there. Whoa! Got actually pretty wet. But that's the nice pressure. That's coming from this pump now. I'm slowly moving my hand down, and I have that spraying out. So this is very good. Just in a small pop can, it's only about 2 inches, 3 inches high of oil, I found a 9 degrees Celsius thermocline, which is great. So now if we look at this, it's at the bottom right now, 94 degrees. Now as I slowly lift the temperature gauge, 95, 96, 97, 98, 99, 100, 101. So this is just me lifting it. So I went up to like 102. So it's a huge difference in temperature. So I had a lot of fun making these tubes. These are for my drawings. So these large engineering drawings and then the smaller ones. This is what I used. I roll this out on a piece of wood or structure to create the parabolic curve to focus light on the pipe. So this is very important. So just having a small one, if I only want to carry that by myself, I mean, I could put it in the bigger tube. But I just have these 2 end caps in. I cut this PVC. It's a very thick wall, so it's super strong. It's made for a lot of pressure. You just have the drawing in there, and then the cap just goes on there. And I put the bottom cap on really tight, and the top one is the one that comes off. But yeah, I'm really happy with these. This is the way I can transport my drawings when we're traveling and everything else, and they don't get damaged. So I cut a curve. This is some of the extra that I had left over. I'm trying to build or find new ways to build these curves. These would be the ones that would hang off the pipe or be rotated in the center for tracking. So I need a very lightweight shell to hold the mirror at the right angle. So I'm thinking about ways of attaching all these different pieces. So I'm going to start, there's going to be I think 7 of these for my 3-foot 1/3 scale test. I'm just seeing how I can glue them. I'm going to try white gluing these 3 pieces and then adding maybe an additional support as well as bracing. See how heavy it is, how strong it is, and then I'll put it all together. But I need some kind of jig like this to hold it in place while it's gluing. Test section for the sun finder. So I'm trying to make this as light as possible, and this is going to hold a mirror there on the curve. There's going to be 7 of these that go together. Not this size, but 7 ribs that go together. And this is going to turn around this pipe, smaller pipe, and it's going to rotate around with the sun. Now I can move this because it still doesn't have a lot of supports. I might add some more supports depending if this is strong enough. But once you put the sheet on this, it's going to add a lot of torsional rigidity, and it should be good. And I'm just covering the model here. This will be where the tinfoil will be for the mirror. So I just cut this to the right. It's just a cereal box. Cut these little notches out of it. I want to make sure that the edge here is all the way glued on. So I can get this all set in there, and then I'm going to weigh it down with bottles. I have some bottles with water to weigh it down to make sure. I want to make sure that it's on the curve all the way across, so it has enough weight to keep it down. Yeah, so a slight breeze knocked this over, and all the hot oil is on the ground now, so that really sucks. That will affect our data greatly. Okay, so I have oil that is 111 degrees Celsius inside a metal tube, and then there's an air pocket with glass. And I can touch the glass and push with my finger, and it just feels warm. Now that's a good insulator. That means the heat from the very hot oil is not going out through the glass and out through the atmosphere.